All right, more proportions, more ratios, and there are going to be some equations in here too. So today we're going to look at some mental computations when it comes to percents, and then we're going to look at some one-step computations when it comes to markups and discounts, and I will explain those vocabulary words in a moment. There are lots of examples here. Please make sure you write down each and every one. So first of all, some mental computations when it comes to percents. Something like 50% you should be able to do mentally, right? We want to think 50% is the same as a half. So if I say 50% of 150, right? I want to be able to say that's, half of 150, which is going to give me 75. So that's a mental computation you should be able to do. There are certain percents that lend themselves to that really easily. 50% is one of them. 10% is another one. So if you remember this one, a 10% is just simply 10 per 100, right? In other words, I can think of percents as division. Be careful that you're not just doing divided by whatever the percent is. When you're taking 50% of something, you don't take your value divided by 50. If I said 50% of 100, you're not going to say 100 divided by 50, right? You're going to say 100 divided by 2, right? That's what you're dividing by. So for this one, again, let's see what you're going to divide by. So if I simplify this, I'm going to get 1/10. So what am I dividing by? Well, in this case, I'm dividing by 10. So if I said 10% of 150, if you recall with taking 10% of or dividing by 10, I simply move my decimal point over one time because it's divided by 10. So 10% of 150 is going to be 15. Well, I want to do one more. About 1%. So if I do 1%, again, that doesn't mean I'm dividing by 1, right? 1% is the same as 1 per 100. Percent just means per 100. So what am I dividing by? It's already simplified. I'm dividing by 100. So if I take 150, or I'm sorry, if I take 10% of 150, I'm moving my decimal point over 1 2 times. So 1% of 150 is going to be 1.5 or 1.5. So remember, it's this denominator that you're dividing by, right? It's not just this value. I'm not going to divide by 50, divide by 1, right? It's this denominator in the fraction that you're dividing by to get that percent. All right, we'll do more of the kind of the mental percents in class, but I want to look at some markups and discounts, and we want to do these in one step only. We're going to look at a couple different methods for that. But what is a markup? A markup is something like a selling price. A store gets an item, right? They purchase an item to be in their store, and they have to mark it up so that when you buy it, the store is actually making a profit. Sales tax is a markup because you're paying the original price and then you're paying more money on top of that. So that's considered a markup. And then goal setting. For example, if I say I ran a mile in 8 minutes and 15 seconds, and well, that's not a good example because that would be a markdown. So it's like a goal setting. Something like a store sells a certain percentage of something and they want to increase that percentage that they sell by 20%. So that's goal setting. We're going to look at some examples of each of those. So the first thing when it comes to a markup is we want to know what the new percentage is, right? 100% is the original. That's what we start with. Like up here it says the current amount. And then n% is what we're marking up. So the current 100% plus some additional percent. So let's look at an example. The items you want to purchase at Target cost $18.39, but then there's also 7.25% sales tax that's added to that amount. So what's the total amount you're going to have to pay? So we're going to look at this as a proportion. So my first step, again, is to figure out what percent that is. Well, I have 100%. is my $18.39. But then I'm paying an additional 7.25% on top of that. So my total percent that I'm paying is 107.25%. So my question is, and I always want to know what the question is, that's going to be really handy. So what is 107.25% of $18.39? In other words, what am I going to pay over and above that $18.39? What's the total over and above that $18.39? Whoops. All right. So again, this is going to be a proportion method. So take a look at this right here. This is going to be a handy proportion to remember. Per 100 is of, right? Is in your numerator, of is in your denominator. But what's the per 100? Well, in this case, my per 100 is going to be 107.25%. Just mean per 100. So 107.25 per or over 100. There's my per 100 piece of this proportion. I said the other piece of my proportion is over of. Well, let's look at where is. Okay, what is? Well, we don't know that what part. Whenever we don't know something, we're going to use a variable, right? So x is. Is goes in my numerator. Okay, and now I'm going to find my of 1839, and of goes in my denominator. So x over 1839. Okay, now I'm going to give you a moment. Pause the video and go ahead and solve that proportion using cross products. In other words, 100 times x, or 100x, equals 107.25 times 1839. So if I multiply that 107.25 times 1839, I'm going to get about 1,972.3. If you do this all on your calculator, you're not going to have to round. Because I'm writing it down here, I'm going to round. So your last step then is to divide by 100. Right? So x equals, if I divide that by 100, dividing by 100 is just moving your decimal point to the left 2 times. We're going to get about $19.72. So there's your proportion method. Just remember we have per 100 equals is over of. Right? So, excuse me. So we're going to take a look at it at a different method here. We're going to look at an equation method. So same type of problem. Subscriptions for a certain magazine are $24.99 per year, but the price is going to go up 11%. So I have 100% plus an additional 11% is going to be my final cost for next year. So my question is, what is 111% of what I have now, which is $24.99? Because this is more than 100%, I know that's going to increase. So this is my second method, my equation method. I still want to remember that that what is a variable, right? I don't know that it's a variable. Is in math is going to be equals. So I'm really just taking an English sentence, I'm translating it into a math sentence. Now you want to remember here for 111%, if I move my decimal point to the left 2 times, I get 1.11. I want to change that percent to a decimal. My writing's going to be really messy here because I'm just working on my computer. So again, I want to change that percent to a decimal. Please write that down in your notebook, star it in your notebook 3 times, underline it, change your percent to a decimal. In math, let's remember that of is times, and then I have $24.99. So if you take a look, all of a sudden I have this nice simple equation. I have x equals 1.11 times $24.99. So if you take your calculator, pick up your calculator, take a look at that on your calculator. 1.11 times $24.99 you should get $27.74. It's just over 100%, right? So 27.74 is just over 24.99. So it looks like that makes perfect sense. So let's take a look at this one. We'll decide how we want to do this one. Company plans to open a branch office in Richfield. The president of the company thinks that they will need 80% more employees, so you can see that's a markup, than they currently have. There are 175 employees now. How many will there be total after the branch office is opened? Well, let's take a look at, I don't try to give too much away here. So let's take a look at least just what our percent is, right? So I have 100% of my employees, but they're going to need 80% more. So 100% plus 80% is going to give me 180%. Now, what's my question? I need 180% of something. What do I need 180% of? Well, my original of 175 employees. So my question is going to be, what is 180% of 175 of what I have right now? Well, I want to do this in the proportion method. So remember, we had percent, right? Well, my percent is 180. 180 per cent or per 100. So whenever you see a percent, that's one complete ratio. You can always make one complete ratio out of a percent. And remember what the other side was. It was is of. Right, so what is my is and my of in this case? Okay, well, what is? So a variable is. So I'm going to replace my top is with my variable. And then I have of 175. So it looks like the 175 belongs in my denominator. So there's my proportion that I can solve using cross products. So again, pause for a moment, and I will and use your cross products. 180 times 175 divided by 100, and then I'm going to show you the answer. So pause, figure that out, and then I'll show you what that answer is. So hopefully you paused that, and you should have gotten 180% is 315 employees, right? That's almost double. So 315 is pretty close to double 175. That makes good sense. All right, let's take a look at another one. I know there are a lot of examples here. This one's a little bit different though. So a salesperson earns 4.5% commission on top of their sales. So they make 100% plus an additional 4.5%. So in total, they make 104.5% of their salary. Okay, so the question is, what amount of sales is needed to earn $8,000? So $8,000 is 104.5% of something. So this one's a little bit different. 8,000 is their final total. So that is over and above, over 100% of what value? So if you think about this reasonably, I should be getting something that is less than 8,000 because they have that 100% plus something on top of that to get the 8,000. Well, let's use the equation method this time. So here's my sentence. So 8,000 is just 8,000. Remember what is equals 104.5%. Turn it into a decimal. 1, 2. So I have 1.045 of is times, and what is a variable? Well, I'm not going to use an x this time because I have a times right here, so we'll just say q. Right, so 8,000 equals 1.045 times q. Now this one has a little bit more involved with it because I'm going to have to solve this. If I want to get q alone over here, times q, well, I want to divide, right? So I'm going to undo that multiplication. I'm going to divide both sides by 1.045 to get q alone. And then that should give me that value, like we said, that should be less than 8,000. So pause, do your 8,000 divided by 1.045. And we should get $7,655.50. All right, let's take a look at this one. Company sets a goal of increasing their online sales by 16%. They meet their goal with sales of 18,900. How many sales were there last year? So let's start with what our markup is. 100% plus an additional 16 gives me 116%. But what's the question? They're going to increase their sales by 16%. And when they increased them, they got 18,900. So that 18,900 is the new total. So my question is, 18,900 is 116% of what? Right? So I'm going to pause here. I'm not going to do this one. I want you to do it. You can use the equation method. You can use the proportion method. Look back in your notes for what we have done before and see if you can come up with your total. So you should get the same value no matter which method you chose. So $16,293. All right, discounts. This is a long one today, guys. So for discounts can be a sale price. It's just a decreased amount of something. It can also be goal setting, like my example from before. If I ran an 8-minute, 15-second mile and I want to decrease that by 10%, that's going to be something that would be considered goal setting. So let's do a couple of examples. Store wants to clear out summer merchandise and advertises a 70% off sale. If the original price of a grill was $289, what's the clearance price? Well, let's take a look. This time we're not adding to get our percentage, we're subtracting. Some percent minus a percent is going to give me that final value, that final percent. So they're advertising a 70% off sale. So think of it this way. If everything is 70% off, you're not paying 70%. That means you are paying 30%. So that's where I'm getting that 30%. So again, the question is really important. So what is 30% of $289? Let's do a quick proportion method. So we have per 100 on the left, right? So my per 100 this time is going to be 30 because there's my percent. So 30% or 30 per 100. And then I have is of. Well, it looks like what is. So there's my variable in the numerator, is in the numerator. And of is going to be in the denominator. So of 289. And again, I'm not going to follow this all the way through. I have my answer up here. But what I'd like you to do, again, is pause. Use your cross products. So 30 times 289. And then divided by 100. 30 times 289 divided by 100 is going to give you, pause, figure that out, $86.70. So let's make sure that makes sense. I'm only paying 30%, less than half. So it looks like $86.70 is less than half of $289. So that looks like a reasonable answer. But let's take a look at another one. Okay, we're just going to do one more, and then the rest of these you can do in class together. A restaurant has an employee discount of 72% on all meals. The regular price is $9.80. What is the cost for an employee? So the cost for an employee isn't 72%. The cost is 100 minus that 72%. Okay, whoops. Okay, looks like that got turned a little bit. So if I look at what my percent is, I have 100% minus 72%. So I'm paying 28% for my meal. I'm getting 72% off of the meal. That's what I'm not paying. So I am paying 28%. So what's my question? What is 28% of $9.80? Let's use the equation method. What is a variable is is equals 28% as a decimal is 0.28 of is times, and then 980 is just simply 980. So I have a pretty simple equation that I can just punch into my calculator. 0.28 times 980. If I make an estimate of that, say 28% is just a little less than a third, right? So what's a little less than a third of about $10? Well, less than a third of about $10 is going to give me somewhere, in the $3 range, right? So let's see if we got that. All right, $2.74 makes sense. And I did lie. I'm sorry. We are going to do one more. The current wait time at a call center is 6.5 minutes. You know what? Let's do this one. I'm going to skip that one. Company sets a goal to decrease their customer complaints by 15%, and they met their goal with 72%. Okay, so let's start with our percent. 100% minus 15, because this is a decrease, is 85%. What is the question? So this time we actually have a total. We have our end amount of 72 complaints. So 72 is the 85% we're looking for of some original. We are looking for the original. So there's our sentence. All right, I'm going to do this as a proportion. So again, percent, so 85 per 100, percents are always ratios, equals is over of. All right, so it looks like 72 is, and then in this case, of what? So of is my variable. So this proportion's a little bit different than the last time we used the proportion method. You're still going to do your cross products. 72 times 100 divided by 85 is going to give you X. So pause before I reveal that answer. And we should get 85. So does that make sense? If there were 85 complaints last month and I decreased that by 15%, does it make sense to say there are now 72 complaints? That looks like a reasonable answer.